now what we're going to do is we're going to talk about solving systems of linear inequalities. Okay, systems of linear inequalities in two variables. Okay, so this is where we're going to now apply the same thing, but we're going to now apply it to two inequalities at the same time. So we're going to graph both of these, and then we can use test points to see which regions we're going to so once we graph them, we'll look at where the overlaps are at, because in order to solve a system of inequalities, we have to make sure that all or both of the inequalities are true. Okay, so that's going to be where both solution sets overlap in the graph. Okay, so let's graph the first one. So this one here, we're going to graph the equation. So y equals 1/2 x plus 2. So the intercept is at 2. And it goes up by 1/2 or down by 1/2. So it goes up 1 and over 2. So up 1 over 2. And then up 1 and over 2. And it goes down 1 over 2. Okay, like so. And so here we'll go 1 over 2. Okay, and we'll draw the line. Okay, so this here, I'll just say this is y equals 1/2 x plus 2. So, and it's equals, so it's a solid line. Now, this one here, I'm going to, we can plot the intercepts if we want, right? So that would be at 0, -3, right? So if x is 0, y is -3. Okay, so again, if we use the equation, so if x is 0, we get 0 minus y equals 3, right? So this is a negative y, so we divide both sides by -1, and we get y equals -3. So 0, 3, or excuse me, 0, -3. So here's this one. And then if we go back and we say, and make the y 0, get the x-intercept, when y is 0, what happens? X becomes 1. Okay, so we can see the slope is what? 3 over 1. So the slope looks like it's 3, right? So if we go 1, 2, 3, 1. Okay, so we get something that does that. Now this is a strict inequality, so this is going to be dotted. Okay, so now we have the two graphs, or the two equations, right? The two lines. These are our boundary lines, right? Now, we have 4 regions that we can test. Okay, so if we have, so this is one way of doing it, right? You could put a test point in here, right? So it's only going to be either this side of, oh, hold on, so this is 3x minus y is equal to 3, okay? So it's either going to be shaded above this line or below it, or it's going to be on this side of this line or on this side of this line, okay? So what we need to find out is where the shaded regions overlap. Okay? So we could use a test point for the first one, right? So we could test a point here, or in fact we could do the origin, right? The origin is very simple. We could plug in the origin for the first one, right? And what do we get? If we plug in 0, 0, we get 0 is less than or equal to 2, which is true. So that means we're going to be below this line, right? So let's do that. So we're going to be below this line, right? Now, but let's put in the origin is also, we can test it for this one too. Let's put the origin for this one. If we put in 0, 0, what do we get? We get 0, right? We get 0 is less than 3, which is also true. Which means for this line, that's telling us that we're shading above it, right? So everything on this side of the line. So let's do that. Right? Now, what do you notice? You notice that the overlap is right in between these two up to the intersection point. Okay? So the solution region is right in here between the two lines. Okay? And so, and then of course, we want to know what this intersection point is. The intersection point looks like it's 2, 3, right? But let's show, right? So let's show where these two lines intersect, right? So we take y equals 1/2 x plus 2, and we say y equals, let's solve for y here. This is going to be negative y equals 3 minus 3x, and then we're going to multiply everything by negative 1, which gives us y equals 3x minus 3. Okay, so we get 3x minus 3. And of course, now to find the intersection point, we set these two equal to each other. So we get 1/2 x plus 2 is equal to 3x minus 3. And now we're going to isolate the x. So we're going to subtract 1/2 x from both sides. And we're going to add 3 to both sides. So these cancel. And what do I get? I get 2.5, right? I get 2.5 x is equal to 5. Right? So 2.5, I'll write that as 2.5, right? 2.5. Now if I multiply everything by 10, I get 25x is equal to 50. I can do that. And now if I divide both sides by 25, I get x is equal to 2. Right? So I get x is equal to 2. And now if I go back and plug in my value, right? So if I plug in 2 for x, I get 6 minus 3, which is 3. So I get the same point, right? So now, keep in mind that your graph, when you sketch your graph, it's not always going to be obvious where they intersect, okay? Because again, we're freehanding, right? So it's, our graphs might not be nice and neat. You want to make them as nice and neat as possible, so for you to be able to read, and for me to be able to read if I'm grading it, but always verify where the intersection point is. So here, I saw that it went through the same point that I had plotted, so that was 2, 3. But in a lot of cases, it won't work out that way. Okay? All right. Have a great day.